Okay, so we're going to go over completing the square. And instead of just showing you guys algebraically, we're going to try to use these tiles to make a visual representation of it. So first question we're going to take up, example 2 in your book. And it tells you to complete the square for x squared, page 208. Plus 6x plus 5. That's right. Okay. Now, what they mean by completing the square is what they want you to do is to change this from standard form. Yeah. And remember, our standard form is y equals ax squared plus bx plus c. Factoring it will take us to where?
Vertex.
What form?
Vertex form.
There's 3 forms. We have standard, vertex, and factored. So factoring it will take us to what form? Factored form. Okay. Completing the square takes us from standard form to vertex form. And remember our vertex form, y is equal to a. We still have the a, x minus h squared plus k. Okay. Same ideas. Important to notice that the a in both are the same, okay? There is an a, so the a will be the exact same in both. H, though it's in blue and b in blue, they will not be the same number, and same with k and c. That's why we write them as different letters. They don't actually equal the same thing. So, I've already set this up with the algebra tiles. We have 1x squared, okay? I have 1, 2, 3, 4, 5, 6x, so 6 tiles representing x, and I have 1, 2, 3, 4, 5 tiles representing positive 1. The goal of this,
Positive 1 be positive 5?
they add up together to equal positive 5. That's right. So the goal of this, so when we talk about completing the square, what we're going to actually try to do with these visuals is we're going to try to make a square out of them. Okay? So we already have x squared, which is clearly a square. And I'm going to try to stack these x's beside them until it creates a square, or close to a square shape. Now, I'm not exactly accurate with these. Like the image in the textbook. Now, I've stacked 3 on top of it. I'm going to try to stack 3 beside it as well, just so it's kind of even, because we know that a square has an even side lengths for both. Okay, so I'm going to turn these ones around. Oops. And we're going to move these 3 over, just so our side length, kind of like a width and a length, are going to be the exact same. Okay, now what's important here, I know they're not exactly flush, but in order to complete the rest of the square, I need to fill this space here. And what it looks like, if we look at rows and columns, I'm going to need something that's going to be 3 by 3. Okay, so we'll do this in permanent marker here. That's right, we don't actually have that. Okay, so I'm going to need something that's 3 by 3, or in other words, we're going to need 9 of something in order to complete this. So, if we take a look at what we actually have, I only have 5. So these 5 are not going to fill this up. So what I'm going to need to do is borrow. Okay? Just like in completing the square, when we do it algebraically, all right, I'm going to quickly do it algebraically underneath. I want to show you what we're talking about. Normally what we do, not in blue, student black, is we divide by our a term. What is our a term right now?
X. Good. At 1.
1, that's right. 1 would be the a term. Okay? So I would actually take the a term out of both the first 2 terms. I would divide both of them by. But when I divide both of them by 1, is that going to change anything?
No.
No. Okay? So all I'm going to do is encompass them in brackets right now.
So what if you
Plus
can't
that.
divide them by something?
If you can divide them by something, then you would. We'll do an example of that
I mean,
next.
just put outside the bracket.
Yeah. So, okay, let's say we did this by 1. We put it outside the bracket.
Yeah.
So we took a common factor of 1 out. Now, what I'm going to have to do here, this is the visual representation of this, is normally I would take this value here and plug it into a small equation. The equation looks like this. It's b divided by 2 squared. Okay? So our new b, which is our 6x, I'm just going to move these.
You have it highlighted on.
Okay, so our new term for b's, we're going to say it's the x. Now, if I divide it by another term other than 1, this would have changed from here. But this is our new b, and this is what's very important. We're going to take this b term, and we're going to divide it by 2, and then square it. So what is 6 divided by 2?
9.
And 3 squared? What is it?
9.
9. Now, notice that that is exactly how many we need here. Okay? So in order to do this, what we're going to do is, in this version, I would actually have to add and subtract 9 to this equation here. Okay? I would actually have to add and subtract 9 inside. So what it becomes is y is equal to 1 x squared plus 6x. You're exactly right. If I add and subtract 9, it's the same as essentially doing nothing, right? It's adding and subtracting a number that's going to cancel each other out. But the point is we're going to create a perfect square trinomial, and the visual is we're going to create a perfect square. So we're going to add and subtract 9 in here. Okay? Plus 5. Okay, so we're adding our 9 inside of it, which is important. These were the 9 we were talking about. So when I'm talking about adding 9, I got to bring up the tiles. Sorry, give me a sec. Now, so if you notice, I just brought up I have 9 positive and 9 negative, which is exactly what we figured out over here. And by looking at this, we knew what we needed. We knew we needed the 9. Now, in order to complete my square, I have to use these positive 9 here. Okay? We're going to always use these positive terms. So I'm bringing the positive 9 over. Okay? And that's completing our square. This is roughly, I know because I was not perfect in drawing this, this is roughly our square. Okay? We use those 9. Now, what happens is I have 9 negatives left over. Okay? In order to use these, I had to bring in an extra 9 negatives. So algebraically what's going to happen, algebraically what's going to happen is we're going to take this negative 9 outside of the brackets. Now in order to do that, I need to multiply by my a term, which is 1. Now is that going to make a difference when I multiply negative 9 by 1? No, it's going to be the exact same term. So now what's going to happen is we have y equals 1 x squared plus 6x plus 9, okay? And then negative 9 on the outside plus 5.
So wait, what's the point of multiplying everything by 1 again?
We have to in order to bring this out. So
Oh, to bring it out. Oh.
what we've done here, this is very important. This x squared plus 6x plus 9. That is completing or making a perfect square trinomial. And if you look, we have 9 positives, we have 6 x's, 3 and 3, and we have 1 x squared. So visually they complete a square. They're making a square for us, which is a perfect square trinomial. And a perfect square trinomial means it can be factored into one bracket squared. The two factors themselves, say example x plus 2, are going to be the exact same thing. Okay? So if we look along the sides of this, I can tell you what the factors are. Okay? Let's think about if I'm just looking down the width. Okay? We'll call this the width. What consists of the width? How long is this in terms of tiles? X represents one side of x squared, correct? So this side length would just be x. Okay? Because in order to create this entire square, I would multiply x times x. So this much of it consists of x. Okay? Now, the next 1, 2, 3, those are exactly right here. Those are our constant terms. The rest of the length is positive 3, and going up this way, it's 1, 2, 3, plus 3. Okay? So in other words, when I go to factor this, I know that algebraic this looks a little funny. I'm going to write this horizontally instead of vertically. X plus 3. Okay? So if you notice, I have the exact same bracket. So when I go to factor this, and we're going to do the factoring just to show you, but I can just represent that as x plus 3 squared. Okay? And that's what we were trying to make. So when we go to factor this bracket now becomes x plus 3 squared. We've dealt with that. And I'm going to quickly go until you guys remember your factoring rules. I take factors of the first term, 1x and 1x. Factors of the last term, 1 and 9, 3 and 3. And remember, they got to add up to what?
6.
Yeah, positive 6x. What am I going to use?
3 and 3.
3 and 3 and 1 and 1, right? So I get 3x, 3x. So my factored form,
Plus 3.
yeah, I'm just going to draw a line so you guys know that this is kind of a side calculation here, okay? So when we go to do this, I still have y equals 1, and I have two sets of brackets, x plus 3, x plus 3. So visually, with the square, we're able to just count across the side and figure out what the factor of it would be. We still have -9, +5 on the outside, and I can represent this as just x plus 3 squared minus 9 plus 5. Now I want you to take a look at how close we are to vertex form. I already have an a. My a value is 1, which was the exact same as standard form. I have an x minus h, which is x plus 3, and we still have our squared. The last thing we need to figure out is k. Now algebraically, this is a really easy concept, the k. What's -9 plus 5? -4. Very easily algebraically. Visually it's a little tougher.
Yeah, it's actually kind of
Okay?
Yeah.
What I want you to notice visually is because remember to make this +9, I had to include a -9. So I'm sitting on the outside of the square. These are two things that are outside of the square. They haven't been used in the squared factor. So I have 9 negatives and 5 positives. So essentially you could think of creating zeros or canceling out, as you might call it. I have 1 negative, 1 positive, 1 negative, 1 positive, negative, positive, negative, positive, negative. How many am I left over with here? I'm left with 4 what? Positive or negative ones? 4 negative ones. So this tells us right away, after all of these things cancel out, my perfect square trinomial is going to be x plus 3 squared and then minus 4. So visually, that's what completing the square looks like. Algebraically, that's what we've done down here. The steps are a little harder to remember. That's why the visuals sometimes help in terms of setting up all of the steps. Okay, this one, completing the square. We have a bit of a different question here. Now, if you take a look, this deals with -3x squared, -12x's. So that would be 3 of these, 12 of these, and -11, we're looking at 11 of these. But when we complete the square, we only want to be working with 1x squared, okay?
What's that?
And we want it to be positive. Because in our vertex form, when we have x minus h squared, the x is technically +1. So that's all we want our first term, once it's technically been factored, that's all we want it to be. So in order to do that, what I need to do is I need to divide the first two terms by the a value, whatever the a value is. So what is our a value here?
-3.
A is -3. So I'm going to divide both of these terms by -3.
And you're doing that because they both have x's, right?
The reason we're doing that is because we're creating a 1. So the -3 comes outside of the brackets,
Well, how come you don't
and it
take
becomes our a term for the vertex. We did it in the other one. We only divided by 1, though, because there was no number. -3 divided by -3 is 1x squared. I don't really need to write the 1. We know we just have x squared. -12x divided by -3 is +4x. So that's going to change the numbers we need. Okay? -11. So this is what we're focusing on right now. Okay? We're going to focus on, well, we have these terms, our x squared, our 4x, and our -11 here. So I took out exactly what we needed. We needed 1x squared, we needed our 4x's, and our -11. Okay? We're going to keep our a to the outside. It's not important for our completing the square or creating a perfect square trinomial. So right now I have my 4x's. Yeah, exactly. I need to create a larger square. So because I have 4 of them, I'm going to divide them in half, put 2 on top and 2 on the side. Essentially is what we're going to need to do every time. Take your x's, divide them in half because we have a square. There we go. 1 and 2. Okay, so we have 2 on top, 2 on the bottom. So we've set up our square, and what I'm going to need here, yes, we got to figure out exactly what we're going to need. We're going to need a slot that's going to be 2 by 2, or in other words, 4. So what that means is I need to add and subtract by that same number. So I'm going to need 4 positives. So we'll quickly take them out here. 1,
And 4 negatives, right?
2, yes, exactly. 2, 3, 4. And we're going to need those same 4 negatives, just so it's like we're not actually doing anything. We're adding and subtracting by the same number. We're creating what's called a 0, you could say.
So, is there a way to figure out how many you need by not looking at it in tile form?
putting it up in top form here is the way you would tell. So we have our groups here. Okay, so just as a side note, these are just manipulatives on the side, and we have our 4 and our 4. So I take my 4 positives and I put them in. We now have a square. So before I even do anything algebraically, so we've completed our square. Now before we do anything algebraically in here, I want to see if you guys can remember what that means in terms of factoring. What's this going to look like?
X.
How long is this part here? We have x.
X plus 2.
That's right, plus 2. So this means how long will this be?
X plus
X plus 2. Very good.
X plus 2
Squared. Exactly. Good, good, good. So we have our x plus 2 squared for our width
X plus 2 squared.
and x plus 2 squared for our length. So in other words, we can just represent both of those as x plus 2 squared.
A.
Okay? Now, there is the important part here. Now, this is a little tricky, okay, with the tiles. Now, it's important that we notice that we did take out by -3, okay? So, in order to do that, these numbers we added in, or our -4 here, remember that's still in play, and we still have these -11 over here. I'm going to erase some room here. Now, what happens is, technically, algebraically, I'm going to try to squeeze it in here. We get -3x squared plus 4x. And remember, we added and subtracted 4, correct?
Yeah.
So we added 4 and subtracted 4. Now, the problem is we've already used the positive 4. We've done that, and we factored. We already know what we had to do with that stuff there. But the -4, it's inside the brackets. Remember I told you it needs to go outside of the brackets, this number. And when it goes outside, what do I have to multiply by? By my a term. So I got to multiply by -3. So in other words, these 4 negatives need to be multiplied by our -3, our a term. What are they going to become? That's right. They're going to now become positive 12. And in other words, I'm going to have to bring out 12 of these guys here. So we'll start with 1, and I'm going to pause and bring them all out at one time. So the reason we have to multiply by 3 is think of our distributive property. Technically, this -3 is multiplied by everything inside those brackets. So in order to just remove one thing from the bracket, it has to be multiplied by this -3 because of distributive property. Okay, so we've now finally put in our 12 positives. How many negatives do we have?
11.
So they're all going to cancel out here. What am I going to be left with?
1.
Positive or -1? We're going to be left with just positive 1 here. So I can kind of jump straight into my factored form. I know we're going to have -3. What's my bracket going to be?
X plus 2 squared.
X plus 2 squared. And outside we're going to be left with
15
Plus 1.
15.
positive 1. These all canceled out. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1. Whoa. Oh, I missed one. There we go. That's one thing. There we go. So we have 1. 1 left. So this is our vertex form using our algebra tiles.